The outer solar system begins where warmth fades and sunlight thins into memory. Beyond the bright certainty of Mars and Jupiter lies a realm shaped by cold patience and ancient violence. Here the planets do not simply orbit. They whisper contradictions into the laws that formed them. Worlds that spin on their sides. Worlds that radiate more heat than they receive. Worlds whose atmospheres roar with winds faster than any storm on Earth. And moons that hide oceans beneath kilometers of ice. This distant frontier should have been simple. Born from the same disk of dust and gas that created Earth and the Sun. Obedient to gravity and time. Yet every time humanity looked outward, the outer planets refused to behave. Uranus rolls through space like a fallen god. Neptune burns with internal fire despite its distance from the Sun. Saturn's rings should not exist as they do. And Jupiter's moons resemble miniature worlds more alive than the planets they orbit. This is not a story of many mysteries. It is a single unfolding question. Why does the outer solar system appear fundamentally broken? As if something violent or unfinished shaped it long after the Sun ignited. To understand these distant giants is to confront the limits of planetary science itself. To realize that even in our own cosmic backyard, the rules are incomplete, and the history is far darker than we once believed. In the earliest nights of recorded astronomy, the outer solar system did not appear as a place at all. It was only motion. Small points of light drifting slowly against the fixed background of stars. They did not shimmer like stars nor blaze like comets. They wandered. To ancient observers, these wandering lights were planets in the purest sense of the word. Objects that refused stillness. Saturn marked the apparent edge of this moving order. Beyond it there seemed to be nothing. Only darkness and the assumption that the solar system ended cleanly where visibility failed. For centuries this illusion held. The outer reaches remained invisible not because they were empty but because human sight was fragile. Bound by glass, ground by hand, and eyes trained to search for meaning where none was yet visible. That illusion fractured in 1610 when Galileo Galilei turned his telescope toward Jupiter. What he saw did not immediately resemble a discovery. At first it appeared as small stars arranged in a line beside the planet. Night after night their positions changed. Sometimes they vanished. Sometimes they returned. Slowly an impossible realization emerged. These lights were not stars. They were moons. For bodies orbiting a world that was not Earth. A miniature solar system bound to another planet. Moving with mathematical precision. This single observation destabilized the architecture of the cosmos. If moons could orbit Jupiter, then Earth was no longer unique. If Earth was not unique, then it was not central. And if it was not central, then the universe was far larger and far stranger than scripture or tradition had allowed. The outer solar system entered science not as a location but as a threat to certainty. Yet even then its true scale remained hidden. For more than a century after Galileo, no new planets were found. Saturn remained the last known boundary. And the darkness beyond was again mistaken for absence. That silence ended abruptly in 1781. William Herschel was not searching for a new planet. He was surveying stars, cataloging points of light with meticulous patience. When one object refused to behave, it did not remain fixed. It showed a disk. At first Herschel believed he had discovered a comet. But its orbit was too circular, too orderly, too calm. What he had found was Uranus, the planet nearly twice as far from the Sun as Saturn, invisible to the naked eye, yet massive and undeniable. For the first time in human history, the solar system expanded. This was not merely an addition, it was a rupture. If one unseen planet existed, then others might as well. The cosmos could no longer be defined by what humans could naturally perceive. Uranus carried another secret. As astronomers tracked its motion, its path refused perfection. Small deviations accumulated, minute discrepancies that grew impossible to ignore. According to Newtonian gravity, Uranus should have followed a predictable orbit, but it did not. The planet was being pulled by something unseen. This anomaly became a puzzle that spanned decades. Two mathematicians working independently, John Couch Adams in England and Urbain Le Verrier in France, reached the same radical conclusion. Another planet must exist beyond Uranus, exerting gravitational influence from the dark. In 1846, telescopes were pointed to the predicted location, and there it was, Neptune, found not by sight but by mathematics. It was a triumph unlike any before it. Gravity had revealed what light could not. Newton's equations had reached into the void and pulled a planet into existence. For a brief moment, the universe appeared obedient, predictable, elegant. But that illusion would not survive contact with reality. By the 20th century, the outer solar system was still largely theoretical. Astronomers could measure mass, brightness, and motion, but the planets themselves remained unresolved disks, symbols rather than worlds. That changed in the late 1970s, when two machines left Earth carrying humanity's curiosity beyond the reach of return. Voyager 1 and Voyager 2 were not built to rewrite planetary science. They were designed to observe, to pass by, to transmit. Yet what they revealed transformed every assumption. Jupiter was first, a planet that had long been understood as a gas giant, but never as a system. Voyager showed a world dominated by storms older than civilization, a magnetic field so powerful it carved lethal radiation belts into space, and moons that looked nothing like inert rock. Io erupted with volcanic fury, its surface constantly remade by tidal forces. Europa displayed a fractured icy crust, suggesting a liquid ocean beneath. Ganymede revealed its own magnetic field, something no moon was supposed to possess. Jupiter was not a planet with moons. It was a solar system of its own. Then came Saturn, its rings revealed as intricate structures shaped by gravity and resonance. Its moon Titan cloaked in a thick nitrogen atmosphere, richer and more complex than scientists had dared predict. But it was Uranus and Neptune that delivered the deepest shock. Uranus emerged as a planet fundamentally misaligned with expectation. Its axis tilted so severely that its poles faced the sun, its seasons lasting decades, its magnetic field skewed and displaced. Not centered, not stable. There was no gradual explanation. Only violence could account for such an orientation. Neptune followed, a world farther from the sun than any known planet, yet internally warm, its atmosphere driven by winds surpassing 2,000 kilometers per hour, storms forming and dissolving with frightening speed. According to every thermal model, Neptune should have been cold and still. Instead, it burned with hidden energy. Voyager revealed magnetic fields tilted and offset on both ice giants, fields that did not align with rotation, fields that seemed to emerge from shifting interiors. Moons once assumed frozen were active. Triton vented nitrogen geysers into space, orbiting Neptune backward, a captured world rather than a native one. What scientists believed would be the quiet graveyard of planetary formation was instead alive with motion, instability, and contradiction. The outer solar system did not resemble a calm extension of the inner planets. It appeared broken, as if shaped by forces that no longer operated, or scars from events too violent to repeat. By the time Voyager 2 transmitted its final images, it was clear that the discovery phase was not over. It had only begun. The planets beyond Saturn were not simply farther versions of those near the Sun. They were fundamentally different. Their histories encoded not in smooth evolution but in disruption. The outer solar system had revealed itself not as a distant boundary, but as a record of chaos, preserved in cold and darkness, waiting centuries for human curiosity to finally reach it. The shock did not arrive as a single revelation. It arrived as fracture after fracture, each discovery breaking a different law, until the idea of a calm, orderly outer solar system collapsed entirely. Uranus was the first undeniable wound in planetary logic. A planet should spin upright, its axis tilted only slightly by the slow inheritance of angular momentum from the disk that formed it. Earth tilts by 23 degrees, Mars by 25. Even Saturn remains within expectation. Uranus does not. lies on its side, an axial tilt of 98 degrees. A world rolling around the sun like a toppled monument. For half of its orbit, one pole stares directly at the sun, enduring decades of constant daylight, while the opposite hemisphere freezes in darkness. Then the roles reverse. No standard model of planetary formation allows this. Gas and ice giants form gradually, their spins stabilized by mass and symmetry. Nothing in that process produces a sideways world. To explain Uranus requires violence. Something massive, something late, a collision with an Earth-sized or larger body, striking with enough force to knock an entire planet onto its side. But even this explanation struggles. Such an impact should have destroyed Uranus's moons, should have stripped its atmosphere, should have left chaos too obvious to miss. Instead, the system survived, distorted but intact, as if the solar system absorbed catastrophe and continued forward without pause. Neptune delivered a different kind of shock, quieter but no less profound. At its distance from the sun, solar energy is weak. Sunlight is pale and diluted, barely more than a suggestion. Thermal models predicted a cold, inert world. Slow winds, minimal activity. Neptune ignored every prediction. Voyager measured temperatures that made no sense. Neptune radiates more than twice the energy it receives, heat pouring from its interior without a known source. Its atmosphere moves with terrifying speed, winds screaming faster than sound, storms forming vast dark scars across its surface. Where does this energy come from? Why has it not dissipated over billions of years? The planet should have cooled. It should have settled. Instead, it burns. Neptune's internal furnace suggests that something fundamental is missing from planetary physics. That deep within these ice giants, processes operate beyond current understanding. Jupiter adds weight to this discomfort. Its mass is so immense that it dominates the solar system, shaping not only orbits but space itself. Its gravity warps trajectories, captures asteroids, redirects comets. But gravity is only part of its power. Jupiter's magnetic field is the strongest of any planet, a colossal structure stretching millions of kilometers into space, trapping radiation so intense it can kill unshielded spacecraft. No planet should be this hostile, not at this scale. Yet within this lethal environment, Jupiter's moons tell a different story. Europa should be dead, a frozen sphere of ice orbiting a distant sun. Instead, its surface is cracked and restless, ice plates shifting and fracturing. Beneath that shell lies an ocean, a global sea kept liquid by tidal heating, salt water interacting with a rocky seafloor, an ocean larger than all Earths combined, hidden in darkness. This alone destabilized planetary science. Life was no longer confined to the warmth of stars. Habitability could exist in the cold, powered not by sunlight but by gravity. Jupiter both destroys and sustains. Its radiation belts sterilize. Its tidal forces create oceans. The same physics that kills spacecraft may enable biology. Saturn introduces a different paradox. Its rings are among the most recognizable structures in the solar system. Broad, bright, and impossibly thin, composed of ice and rock arranged with precision. For centuries they were assumed ancient, born alongside the planet, the permanent adornment. But measurements tell a different story. The rings are clean, bright, unweathered. Micrometeoroids should have darkened them over billions of years. Radiation should have altered their composition. Gravitational spreading should have dispersed them. None of this has happened. The rings appear young, perhaps only a few 100 million years old, a recent feature in a 4.5 billion-year-old system. Their origin implies catastrophe, the destruction of a moon, a tidal breakup, a collision that shattered a world and left its remains trapped in orbit. Saturn should not have rings like this. No, not so pristine. Each planet violates a different expectation. Magnetism, structure. Individually, these could be dismissed as anomalies, rare outcomes of chance. Together they form a pattern, The outer solar system is not gently evolved. It is scarred. It bears the marks of instability, of migrations and collisions, of rearrangements that occurred long after formation. The planets do not resemble siblings raised in the same environment. They resemble survivors of a shared disaster, each carrying different injuries. This realization shook the foundation of planetary science. For decades, models assumed smooth evolution, planets forming where they are found, cooling gradually, stabilizing over time. The outer planets refuse this narrative. Their properties suggest movement, exchange, violence. Jupiter may have migrated inward and outward, scattering material, altering orbits. Neptune may have captured moons instead of forming them. Uranus may be the remnant of a collision that reshaped its destiny. Saturn's rings may be evidence that destruction did not end in the distant past, but continued into relatively recent cosmic history. The solar system no longer appeared finished. It appeared unsettled. What once seemed like the quiet outskirts of a stable planetary family revealed itself as a record of chaos preserved in cold. The shock was not fear. It was humility. If the outer solar system could violate so many expectations, then the laws governing planets were incomplete, and Earth's own stability might be more fragile than assumed. The outer planets did not simply challenge models. They dismantled certainty. They suggested that order emerges not from calm, but from survival. That what exists today is not what was planned, but what endured. And in that realization, the outer solar system ceased to be distant. It became uncomfortably relevant. As the first shock faded, another phase began. Not of awe, but of interrogation. Voyager had shown that the outer solar system was broken. Now science had to ask how. Neptune was no longer a distant blue dot. It became a moving laboratory of extremes. Voyager's instruments measured winds surpassing 2,000 kilometers per hour. Jet streams tearing through an atmosphere receiving almost no sunlight. Storm systems forming and dissolving with a violence unmatched anywhere else in the solar system. These were not surface winds driven by solar heating. They were powered from below, from an interior still releasing energy after billions of years. Thermal imaging deepened the mystery. Neptune glowed, radiating heat that should not exist. Internal temperatures far higher than models predicted. Something inside Neptune was transporting energy outward with remarkable efficiency. But what? Standard planetary cooling could not account for it. Radioactive decay was insufficient. Residual formation heat should have dissipated long ago. The planet was too active, too alive. Uranus offered no relief. Thermal scans revealed the opposite problem. Unlike Neptune, Uranus emitted almost no excess heat. Its interior appeared dormant, as if its thermal engine had been switched off. Two planets of similar size and composition, formed in similar regions, should not behave this differently. One burned, one slept. This contradiction fractured the idea of a unified class of ice giants. Magnetometer data added another layer of unease. Earth's magnetic field aligns roughly with its rotation. So does Jupiter's. So does Saturn's. Uranus and Neptune defy this pattern. Their magnetic fields are tilted at extreme angles and displaced from their planetary centers, as if generated by something broken or shifting. The fields wobble, expose moons to fluctuating radiation environments. To explain this, scientists proposed that the magnetic fields arise not from deep metallic cores, but from shallow layers of ionic water and ammonia, conductive oceans under pressure. This idea solved one problem and created another. If magnetic fields are generated in shallow layers, then the interior structures of these planets are fundamentally different than expected. The ice giants were not simplified versions of gas giants. They were something else entirely. Simulations of Uranus's formation failed repeatedly. No gentle process produced its 98-degree tilt. No gradual accumulation of mass could tip a planet so completely. Only catastrophic impact scenarios succeeded. A collision with a massive protoplanet, striking at just the right angle. late in formation. Such a collision would have altered internal layering, possibly explaining Uranus's lack of internal heat. By disrupting convection and trapping energy, the planet may be thermally strangled, its heat locked beneath stable layers unable to rise. Neptune may have retained active convection, explaining its internal fire. Two worlds, separated not by composition, but by history. Atmospheric chemistry complicated matters further. Spectroscopy revealed unexpected ratios of methane, ammonia, and hydrogen. Methane gives Uranus and Neptune their blue color, but its distribution was uneven. Ammonia appeared depleted, water invisible, locked deep within. These chemical fingerprints suggested formation in colder regions than previously assumed, or migration from elsewhere. The planets may not have formed where they now reside. They may have traveled, dragged by gravitational interactions with Jupiter and Saturn, reshaped by orbital chaos. As scientists debated planetary interiors, the moons refused to remain quiet. Titan emerged as a world with weather, clouds, rivers, but not of water. Hydrocarbons flowed across its surface, methane and ethane cycling through an atmosphere rich in nitrogen. Organic chemistry unfolding in slow motion. Complex molecules formed, broken, reformed. Not life, but precursors. Titan became a time capsule, preserving chemical pathways that may resemble Earth before biology. Far from the sun, in cold darkness, chemistry thrived. Enceladus pushed disbelief further. This small moon should have been frozen solid, geologically inert. Instead, Voyager hinted at youth, smooth surfaces, few craters. Later missions confirmed the impossible. Jets of water vapor erupted from fractures at its south pole, plumes venting material directly into space. These geysers contained salt, organic molecules, evidence of a subsurface ocean. Tidal forces from Saturn heated the moon, flexing it, kneading it. A habitable environment existed beneath kilometers of ice, powered by gravity alone. These discoveries fractured the outer solar system into contradictions. Planets similar in mass behaved differently. Moons smaller than cities harbored oceans. Magnetic fields emerged from unexpected depths. Chemistry unfolded where heat should not exist. The idea of a single narrative collapsed. The outer solar system was not a category. It was a collage. Each object carried its own history, its own scars, its own rules. The deeper scientists looked, the less they could generalize. Models fractured into exceptions. Each new dataset demanded revision. The outer solar system was no longer the quiet edge of planetary formation. It was a laboratory of extremes, record of chaos frozen in time. What emerged was not understanding, but perspective. These worlds did not evolve together. They survived separately, bound by gravity, united by distance, but shaped by chance. The deeper the investigation went, the clearer it became. There was no single explanation waiting to be found, only a web of events, interacting, colliding, diverging. The outer solar system was not a system in harmony. It was a survivor archive, and every new measurement made one truth unavoidable. The history written in cold worlds is not simple. It is violent, and it is unfinished. The mystery did not deepen gently. It accelerated, as observations accumulated and models failed. Planetary science reached an uncomfortable conclusion. The outer solar system could not be explained as a stable relic of formation. It had to be something else, a survivor of instability. For decades, the prevailing assumption had been simplicity. Planets formed where they are found, from a rotating disk of gas and dust, cooling and settling into predictable orbits. That assumption began to fracture under pressure. Computer simulations incorporating all known data refused to stabilize. When scientists attempted to rewind time, to reconstruct the early solar system, the models erupted into chaos. Orbits crossed. Resonances formed and broke. Massive bodies scattered smaller ones like debris. The farther back the simulations ran, the more violent the system became. This led to a radical idea. The outer solar system did not experience all its upheaval at birth. Much of it occurred late, hundreds of millions of years after formation. A delayed instability. In this scenario, the giant planets did not remain fixed. Slowly at first, then suddenly, Jupiter emerged as the central disruptor. As the most massive planet, its gravity dominates the architecture of the solar system. Even small shifts in its orbit would have profound consequences. Models suggested that Jupiter may have migrated inward toward the Sun, before reversing direction and moving outward again. A celestial recoil. During this migration, Jupiter would have destabilized everything beyond it, scattering planetesimals, altering orbits, injecting chaos into regions once calm. Saturn followed, locked in gravitational resonance with Jupiter, amplifying instability rather than damping it. Together they became engines of disorder. This movement rippled outward. Uranus and Neptune did not remain untouched observers. They were participants. As Jupiter and Saturn shifted, their gravitational influence forced Uranus and Neptune into new configurations, causing close encounters, orbital crossings, near collisions. In some simulations, Uranus and Neptune even swapped places. The solar system was no longer a tidy hierarchy. It was a crowded arena. This chaos provides a chilling explanation for Uranus. A sideways world does not require coincidence. It requires collision. The planetary embryo, perhaps several times the mass of Earth, striking Uranus late in its history. Such an impact would explain its extreme axial tilt, its disrupted interior, its suppressed heat flow. The planet survived, but only barely. Its moons may be remnants of debris reassembled after impact. Its internal layers scrambled into thermal silence. Uranus became a scar preserved in orbit. Neptune tells a different but related story. Its largest moon, Triton, orbits backward, opposite the direction of Neptune's rotation. This is not how moons form. Regular moons emerge from disks around planets, orbiting in the same direction. Predictable. Triton violates every rule. Its retrograde orbit suggests capture. A world once independent, dragged into Neptune's gravity and trapped. Such a capture would have been catastrophic. As Triton spiraled inward, its gravitational interactions would have destabilized Neptune's original moon system, causing collisions, dejections, destruction. The moons seen today may be survivors of that event, not originals. This capture could also explain Neptune's internal heat, tidal interactions injecting energy, stirring convection, keeping the planet active. Neptune did not form peacefully. It stole. As these scenarios converged, a larger picture emerged. The outer solar system did not crystallize once. It reshaped itself repeatedly. Planetary migration was not an exception. It was the rule. Gravitational scattering did not occur briefly. It cascaded. Colossal impacts were not confined to early chaos. They arrived late, when the system should have been stable. The implications were profound. If the solar system experienced a delayed instability, then its current configuration is not inevitable. It is accidental. Earth's survival becomes uncertain. During Jupiter's migration, inner planets may have been bombarded or destabilized. The asteroid belt may be the remains of material prevented from forming a planet, or a graveyard of worlds disrupted by giant planet movement. The late heavy bombardment, a spike in impacts recorded on the moon, may be the echo of this reshuffling. The solar system bears scars everywhere. Once scientists learned how to see them, this reframed the outer planets entirely. They were no longer anomalies. They were witnesses. Each carried evidence of a violent chapter, written not in text but in tilt. Orbit. Chemistry. The solar system did not emerge from chaos once. It returned to it, and survived. Barely. This realization transformed the mystery. The question was no longer why individual planets behaved strangely. The question became how anything remained intact at all. Why did Earth not collide with Venus? Why did Mars survive? Why does the solar system still exist? The outer planets appeared not as distant curiosities, but as warning signals. They suggested that planetary systems are unstable by nature, that migration and collision are common, that calm configurations are temporary. Our solar system may be an exception, or it may simply be young. If this violent reshuffling could happen here, could happen anywhere, and if it nearly destroyed our own architecture once, it could happen again. The escalation was complete. What began as odd planetary behavior had become a story of near annihilation, a system that almost did not survive its own gravity. The outer solar system did not whisper this truth. It shouted it across billions of kilometers. Order is not guaranteed. Stability is borrowed. And survival is written in scars. The mystery no longer deepened quietly. It threatened everything we thought we knew about how worlds endure and why we are still here. As the violence of the outer solar system came into focus, science did what it has always done when certainty collapses. It began to imagine structures large enough to hold the damage. The most influential of these frameworks became known as the Nice model, named not for elegance, but for the city in which it was conceived. In this vision, the giant planets were never meant to stay where they are. They formed closer together, locked in gravitational rhythms, orbiting in a tighter, more compact system. Beyond them lay a vast disk of icy debris, countless small bodies, quite patient. For hundreds of millions of years, the system appeared stable. But stability was an illusion. As Jupiter and Saturn slowly shifted, they crossed a gravitational resonance, a precise ratio in their orbital periods. That crossing acted like a trigger. Orbits destabilized, energy transferred, resonances cascaded. Uranus and Neptune were thrown outward, plunging into the debris disk, scattering material, capturing moons, tilting axes. In this model, Uranus did not slowly fall sideways, it was struck or repeatedly torqued by encounters with massive bodies. Neptune did not politely grow its moons. It seized them. Triton became a trophy of chaos, a captured world marking the violence of migration. The Nice model explains much: the distribution of Kuiper belt objects, the late heavy bombardment, the eccentricities of giant planet orbits. But it does not explain everything. It requires fine timing, specific masses, specific initial conditions. Small changes collapse the outcome. And so alternatives emerged. Some researchers proposed that the solar system once hosted an additional giant planet, a fifth or even sixth massive world, formed alongside Jupiter, Saturn, Uranus, and Neptune. In this scenario, the missing planet was ejected, flung into interstellar space, becoming a rogue world wandering the galaxy. Its absence would explain lingering instabilities, gaps in orbital architecture, unaccounted momentum. The solar system we see would be the remnant, not the original design. Other theories reach beyond the sun itself. In the crowded stellar nurseries where stars are born, close encounters are common. Another star may have passed nearby, so close enough to tug. Such a flyby could distort orbits, tilt axes, strip material, and inject long-lasting instability. A single stellar encounter, brief and distant, could rewrite planetary destinies. Evidence for this may linger in the odd orbits of distant objects, bodies whose paths suggest ancient perturbations, as if something massive once passed and vanished. Underlying all of these theories is a deeper mathematical truth. These systems are not linear. Einstein showed that mass curves spacetime, that gravity is not a force pulling through emptiness, but geometry itself. When multiple massive bodies interact, their effects compound, then amplify. Add to this the principles of chaos theory. In chaotic systems, tiny changes do not remain tiny. They grow exponentially. A shift smaller than a dust grain, at the right moment, can alter the fate of planets. This means that perfect prediction is impossible. Two nearly identical solar systems can evolve into entirely different outcomes. The outer solar system may simply be one realization among countless possibilities. Some models push speculation further. They suggest Uranus and Neptune are not true ice giants, but failed gas giants. In the early solar system, the young sun was violent, radiating intense ultraviolet light, stripping atmospheres, driving powerful winds. If Uranus and Neptune formed closer to the sun, they may have begun as gas giants, like Jupiter and Saturn. But before they could fully accrete, solar radiation tore away their hydrogen envelopes, leaving behind dense icy cores. Later migration would carry them outward, frozen relics of unrealized potential. This would explain their composition, their masses, their internal structures. But again, it raises questions. Why did Jupiter and Saturn survive? Why were Uranus and Neptune spared complete destruction, yet left incomplete? Each theory resolves certain contradictions and exposes new fractures. Migration explains tilt, but not thermal silence. Capture explains moons, but destabilizes systems too violently. Stellar flybys explain distant orbits, but leave no clear fingerprint. Failed gas giants explain composition, but struggle with timing. The deeper science digs, the more the mystery resists unification. There is no single master explanation, no elegant equation waiting to close the case. Instead, there is overlap, tension, layering. The outer solar system may be the result of multiple processes. Migration layered atop collision, collision compounded by capture, capture shaped by chaos. Not one disaster, but many. This realization changes how planetary systems are understood everywhere. Exoplanet surveys reveal hot Jupiters, eccentric orbits, worlds hugging stars or flung far away. What once seemed exotic now looks familiar. Our solar system may not be orderly, but it is not unique. It is simply one survivor among many outcomes. In this view, the outer planets are not mistakes. They are records. Their strange properties are not failures of theory. They are data points from a violent experiment that never truly ended. Each theory attempts to read this record, to reconstruct events erased by time. But time has stripped the evidence, smoothed the chaos, left only consequences. The solar system speaks, but not clearly. It speaks in tilt, in heat, in orbit, in absence. And every attempt to translate it reveals both meaning and uncertainty. Theories accumulate, not as answers, but as lenses, ways to look at scars and imagine the blows that made them. In the end, science does not yet know which story is true. Perhaps none are complete. Perhaps all are partially right. The outer solar system remains what it has always been, a place where explanation approaches and then dissolves, where understanding deepens, even as certainty retreats. Each theory illuminates a fragment and casts new shadows. And so the mystery endures, not because science has failed, but because the universe is not obligated to be simple. The outer solar system is not distant because of kilometers or light. It is distant because it resists belonging. It sits at the edge of familiarity, where the language of planets begins to fail, where categories dissolve, and expectation loses authority. These worlds do not confirm what science hoped to find. They complicate it. For centuries, humanity imagined planetary systems as orderly extensions of logic. Dust becomes rock, rock becomes worlds, worlds settle into predictable paths. A quiet inheritance from physics to form. The outer planets deny this comfort. They show that formation is not destiny, that gravity does not promise harmony, that time does not guarantee peace. Instead, they reveal survival, a far colder word. Uranus does not spin as it should. Neptune does not cool as it must. Saturn's rings should not still be here. Jupiter's moons should not be alive with oceans. Yet they exist, not because the universe intended them to, but because they endured sequences that should have erased them. In this realization, planetary science becomes something deeper than classification. It becomes a study of contingency, of paths not taken, of disasters narrowly avoided, of configurations that survived not because they were optimal, but because they were lucky. This truth does not remain confined to distant planets. It moves inward, to Earth. For if the outer solar system is a record of chaos survived, then Earth is not the goal of creation. It is a byproduct, a world spared not by design, but by circumstance. Jupiter may have shielded it, or nearly destroyed it. Saturn's gravity may have stabilized the system, or destabilized it. There is no clear hero, only outcomes. The ground beneath human history rests on orbital chance, on resonances that did not quite cross, on impacts that missed, on migrations that stopped. The outer planets reveal that there was nothing inevitable about this. Earth was not placed gently into a habitable lane. It remained there while the giants fought. Life emerged not because the system was calm, but because it eventually became quiet enough. This reframes humanity's relationship with the cosmos, not as the center, not even as a consequence, but as a survivor. The outer solar system becomes a mirror, not of distance, but of vulnerability. Its tilted axes and captured moons whisper the same message. That stability is temporary. That order is borrowed. That chaos is never far. Even now, these planets continue to move, to exchange momentum, to resonate. The solar system is not frozen. It is merely slow. Given enough time, instability returns. This is not a threat. It is a truth. The universe is not built to preserve. It is built to change. In this light, the outer planets are not failures of theory. They are honest. They tell a story that inner worlds conceal, because survival erased the evidence. Far from the sun, cold preserved memory. Each scar remains visible, each anomaly intact. The outer solar system remembers what the inner one forgot. That creation was violent, that peace was earned, and that nothing about the present configuration was guaranteed. This understanding does not diminish meaning, it deepens it. For if existence is not assured, then its presence matters more. If Earth is not designed, then it is precious, not because it was chosen, but because it remains. The outer planets do not diminish humanity's place. They sharpen it. They show that intelligence emerged not in a universe shaped for comfort, but in one that barely allowed it. That awareness arose on a world balanced between extremes, protected accidentally, sustained briefly, and that this balance will not last forever. The outer solar system does not offer answers. It offers context. It tells us that questions outlive systems. That understanding is always partial. That knowledge advances while certainty retreats. These planets orbit the sun, but they also orbit doubt. They circle the unknown, carrying unresolved physics, incomplete histories, unfinished stories. They remind science that explanation is always provisional, that every model is temporary, that truth approaches in fragments. And this is not failure. It is the condition of inquiry. To study the outer solar system is to accept that mystery is not a gap to be closed, but a feature to be lived with. That the universe is not obligated to make sense, only to exist. And in its existence, it leaves traces. Tilted worlds, burning interiors, broken rings, hidden oceans. Evidence not of design, but of endurance. The outer planets do not comfort. They instruct. They teach that survival is rare, that systems persist against odds, that calm is not the beginning, but the aftermath. They teach that what exists now is not what was meant to, but what remained. And in that lesson, humanity finds itself not diminished, but revealed. A species that arose on a spared world, orbiting a star that did not wander too far, in a system that almost destroyed itself. Still here, still asking. The outer solar system stands as a quiet boundary, not of space, but of certainty. Beyond it, understanding thins, and questions multiply. Yet it does not repel inquiry. It invites humility. It asks science not to conquer, but to listen, to accept that even at home, in the most familiar planetary system known, the universe remains unfinished, and perhaps always will be, not because knowledge is insufficient, but because reality is larger than explanation. The outer planets continue their slow paths, bearing witness. They do not speak, yet they say enough. That order is temporary, that survival is remarkable, and that existence itself is the rarest outcome of all.